Hello guys, welcome back to my channel Meso African Motives. Still working on engineering science N4. So this is actually engineering science N4 that we are having, and we have got a question that I just want us to focus on hydraulics, which is from August 2019, and it's very important that we work out this question, because I've seen that most of the questions that we are having is like an application of this question. Most of them, they're like taking out from this information. So if we can understand what's happening here, it can be much better to in the near future. Okay, so we are given that there is an effort of 210 Newton which is being applied on the lever of a hydraulic press. Okay, so this is applied on the lever of the hydraulic press. The stroke length of the plunger. Okay, so the moment we are given this, guys, let us just take our information so that it can help us. So this is an effort which is applied. Definitely we are working with the plunger here, and we are going to have our ram on the other side. All right, so let's just take this information as this. Okay, so on the plunger here, that is where we have got an effort, which is actually this effort, I write it as FH. It's best for you to just write FH, okay, which is your effort. Okay, in this case, which is 210 Newton, we are given this one, 210 Newton here to the lever. Then the stroke length of the plunger is 100. This is the stroke length, which is your H, which is your stroke length, okay, which is your H in this case. That's 120 millimeters on the plunger, guys. So this is 120 millimeters, of which in meters we can divide by 1000, and this is going to give us 0.12 meters. All right. Then the mechanical advantage of the lever is 18. So we also have the mechanical advantage. Let's just write it here. It does not affect us, which we know, guys, the mechanical advantage. There are so many formulas that we can actually use to find the mechanical advantage. So let's just write it down and move on. The diameters now of the plunger and ram are. So this is the plunger, the ram and the plunger. Okay, so the diameters of the plunger and the ram respectively. So it means plunger is 110 millimeters. Okay, so the diameter here is 110 millimeters, which is actually divided by 100, which is 1000, and you're going to obtain 0.11 meters. Then on the ram now, we've got a diameter of 290 millimeters. That's the only thing that we have on the ram for now, 290 millimeters, which is actually something like 0.29 if we divide by 1000. So taking information is very important. It can help you when we have this. Okay, so the first question is, what is going to be the mass of the object to be lifted by the ram if the efficiency is 93%? Okay, what is going to be the mass? Where are we going to have the mass if we are given an efficiency of 93%? All right, this is the question. So the question is actually mass of an object. We can have this mass if we, let's say, we know the work done here. We know the force that we're going to have here, which is on the ram, which is F ram, or you can just write SWR for the ram, where we know that this is equivalent to mg. So if I divide by g here, that means I can obtain the mass, which is the force that is going to be on the ram over the gravitational acceleration. But where am I going to have this WR? That is the question. I don't have this. All right. From your formulas, guys, remember that we can actually work with any of the two. Okay. That is to calculate this W, which is the force on the ram. Remember, we've got two formulas which are very important. Which are the formulas? The force on the ram over the force that is on the plunger is equal to the distance, that is the diameters that we have corresponding. This is the ram, the plunger, and the plunger. Also, we have got this formula which connects the mechanical advantage, because remember, there is mechanical advantage. So I'm going to write these two formulas, and we are going to, at least, like I said, this is one of the most important questions, and you must know these two formulas. Okay, the mechanical advantage is given by this formula. Okay, that is your FP, which is the force that is on the planche. Let's just write as FP, because here we've used R, so just FP is fine. Okay, over the effort, this one, FH, which is your effort. Okay, so over the effort in this case times 100% over the efficiency, that is to remove efficiency. So this is it. Here we have we want to calculate this, okay, force, because it's the one that is going to give us what? The mass from this equation. Okay, while least we want to calculate this force on the ram, we do not, we have got this, but we do not have the force that is on the plunger. From our information we have, guys, we do not have FP, the force on the plunger here. We just have the effort, we do not have FP. So we are stuck again on another formula, so which means we have to calculate FP. So where are we going to calculate FP? From this formula we have to calculate FP. So let us just make FP the subject. That is, let us just transpose and make FP. Once we have got this, we can substitute here, because here it is going to be like this. To remove this, you just multiply by FP here, by FP here, so this can cancel. So which means the work done that you're going to have, which is the actually force, is this the work done, guys? This is the force that you're having on the what? On the arm. That is remember, it is being pushed there, so that is the one that you're going to have, which is the load that you're going to have. Okay, from your force times what? From your mass times the gravitational acceleration, guys, not force times distance, but acceleration that you're going to have, which is your gravitational acceleration. All right, so this is going to be d squared over d squared times FP, which is the force that we have on the plunger here. So like I said, if we had to calculate this, which means we have got this and we can calculate the mass. So that is where now I was saying, let us now make FP to be the subject. So how are we going to do so? Guys, let us just multiply, remove this efficiency and so forth here, so you can just maybe multiply by efficiency over 100 here, so that we can remove this, multiply by efficiency over 100. I have removed this, so to remove FH I have to multiply by FH here, I have to multiply by FH. So this can cancel, 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 this can cancel. So you just remove by the inverse. The inverse of what you have is the inverse of what you're going to have here. So which means your FP is going to be written as you can just write in any way, guys. You can write as FH, okay, times the efficiency like this, times MA, everything over 100, or just efficiency over 100 is just one and the same thing. So this is your efficiency, or even everything over 100 is just one and the same thing. So that's your force on the plunger here. So this is FH, which is the effort. Okay, and we can substitute our values because we've got everything there. The effort, that's 210 Newton here. So that's 210 times the efficiency, which is your efficiency of what? Of 93%. All right, so guys, working with formulas is very, very important. And the mechanical advantage that is you have got here of 18 all over 100, like that. So that is what you're going to have. And you can actually simplify this using your calculator, and that's gonna be 300, that's 300 of 3,515 comma 4, something like that. So we have got now the force that is on the what? On the plunger there. That is our FP. So now let's take this and calculate our WR, which is on the ram. So the force that you're going to have on the ram there is going to be d squared, which means we are now going back to our d, because we have this from the information. The diameters are there, the diameters are there. So I'm just going to take my diameter 0.29, or I can just use it in meters because that one is a square, so it's not going to affect us. So this one is equal to d squared, that is 0.29 squared, right, over the d squared on the ram, on the plunger, which is 0.11, sorry, on the ram, which is 0.11 squared, times the force on the plunger, which is this one that we obtained here. That's 3515,4 Newton. All right, so that's what you're going to have in this case. So Simplifying properly, guys, we are going to obtain this decimal 24433 something like that. That is from your calculator. You're gonna have 48. I can round off, which is gonna be 48264. So it can be 23, or just use it like that because you are not yet done, because you need to calculate another value. So you can use it like this, or you can use the actual value as it is. Where are we going to find our mass? Remember, here we have made mass to be the subject, and we said as the force that is on the ram over the g, the gravitational acceleration. So that means we can substitute into this formula to calculate our mass, and that will be your mass. Since we said your mass by this formula, so that is your answer now, guys. So just substitute this value, 24433,483, or just the whole value as it was before. Then where are you going to have your g? You remember, this is your gravitational acceleration of 9,8 meters per square second, and this will give us something like 2,493,2125, something like that, and it's gonna be 2493,213. This is gonna change to 3, which is in kgs. So remember, your mass will be in kgs on a particular section like this. Remember, force is equivalent to ma, which is mg, whereby your mass is in kgs. This one is meters per square second, or meters per square second, like that. Okay, so this will be your mass, guys. As you can see, we have calculated our mass from the efficiency and all the information that we had. And let us just see, cross-check the other question that we had and see what we were given now on the other part. As you can see, guys, 5 marks is actually a lot of marks that we have got there. Okay, anyways, we are asked now to calculate the number of operating strokes, which is the strokes that we have if the object in question 6.1, which is this object which has got a mass that we just calculated, is lifted for 410 millimeters and the efficiency is 93, which means we are still at the same efficiency that we had at 93%. But now we want to calculate the number of the pumping strokes, which is the operating strokes in this case, which is n. So let's just say n. So where are we going to have this n? Okay, so we have to at least work around with the formula that consists of n, and also that consists of of the height, which is the stroke length. Now this is your stroke length that you have, your new stroke length, which is your h, which is 410 millimeters, which is in meters is something like 0.41 meters. So that is your stroke length, which is the h. Remember the issue of volume, guys, that we know. There's something that we actually know about the volumes, the relationship of the volumes, that if we can know the volume of the plunge that we are going to have, the actual volume that is working with the plunger there, if we multiply, because we know that if you are talking of volume, let's just say this part, the volume that is going to be affected by the plunger there, which one that has got the stroke length and everything, we know that the volume is equivalent by the area times the height, which is the, when you are referring to the height, you are referring to the stroke length, okay, times the number of pumping strokes. That is what we have got in this case. Okay, so now the question is, if this is the volume that we have got, like on the plunger, okay, let us just write it as if this is the volume that we have got on the plunger in this case, and it has got n, which is the number of pumping strokes inside, then what is the relationship between the two now? The actual volume that is on the ram, because on the ram we have got a volume also, which is given by this formula again, area times the height, but this time it's not like this height here, this one for so let us just put it h like this. This is the height which is affecting the ram, okay, and the height that is affecting the ram in this case, are we given, guys, the height that is going to affect the ram? Okay, take note, guys, this is lifted 0 point, guys. What is lifted is the ram, not the plunger. This is the ram that is being lifted. I hope someone saw this and was like, what is this guy doing? All right, so this is the height that you're already given there. So the relationship now between these two volumes, the volume on the ramp and on the plunger, is that if you multiply this by the efficiency, then they are equal, because it's actually equal. So let's just put efficiency here so that they can be equal. So that's V will be equal to Vs, which is this volume here of A times the area times the height that you're going to have is equivalent to area that is on the plunger here. So this is the area of the ramp, the height that you have on the ramp. So this is the area on the plunger times the stroke length, which is the height on the plunger, times the number of pumping strokes times the efficiency, like that. So that means from this formula, guys, there's a lot of things that I can actually have to find this, because I have got this. So I can actually, this is still on your RAM. So to find this N, I can divide by this, okay, which is the volume times efficiency. So I can divide by area times the height times the efficiency by area times the height times efficiency. I can actually do this, and I'll remain with N, which is the number of the pumping strokes, which is the area on the RAM, which is actually the volume. So it's just area times the height over the area that we are going to have on the plunger, in this case times the height times now efficiency, because we divided by efficiency in order for us to remain with what? N. So all we need is to have this, which is the volume that you are going to have on the RAM. So can we calculate this? Yes, we can. Let us calculate this. So VRAM in this case is going to be, remember I've got a diameter there, we said area times the height, and area, when there is a circular that is a diameter, then that's a circular cross section, it's pi d squared over 4, okay, times the height. So we can actually substitute everything there on the RAM. That is pi times d squared. Remember, guys, on the RAM, from the information that we had here, we had a diameter of 0.29 squared. So this is 0.29 squared over 4 times the height now that we are given, because it is the one that was lifted. It's lifted up, so that is the height for the what? For the RAM. That is that height that it was lifted up by what? By 410 millimeters, which is 0.41. That's 0.41 meters. So that is going to give us a volume which is affecting the RAM in this case, and that's going to be something like 0.027081 or something like that. So you can actually round off, and this will be like cubic meters. So you can even round off if you want to 3 decimal places, but 3 decimal places is going to be something small, like let's just say 3 significant figures, maybe something like that. Or you can just use this value as it is, but this will be the volume that we have on the what? On the RAM in this case. And this is the one that we have got here, remember, where we transposed our formula here. So this one is now there. All right, now on the plunger, do we have anything on the plunger? Do we have anything? Yes, we've got everything there. Also on the plunger, so actually I was just like supposed to just put this here, okay, this formula as it is, I was just supposed to put it here. So like this, instead of calculating this, if I'm explaining, guys, so that you understand. Okay, so you could have just done this way, put it here, or everything here, substitute everything, or you can just calculate aside. Okay, so this is what you're going to have on the plunger. So you can put everything on this formula, then use a calculator, or you calculate them separately. This is what I'm trying to say. All right, so if I am to do this now, I'm going to have this as a number of pumping strokes, which is equivalent already. This one I've calculated this, and I obtained this here, which is 0. Just use the one that you have obtained there. I don't know, you're going to use this is actually, okay guys, let me cross check my calculator once again, because this is 0.9 there, 71, something like that. All right, so anyways, this is what you're going to have, guys. This is 7, okay, so this is 7, not 9. This is 7, 1, okay, we are in the right direction there. Then in this case, remember we have got our, in this case we have got our volume that is on the plunger now, the one, this one, that is this one. So this is the area on the plunger, which is actually pi d squared over 4. Okay, so which means the diameter that we need is the one on the plunger in this case, and we just have to substitute, which is 0.11. Yeah, here you have to just substitute. Okay, so that's what you're going to have on your formula. So that means it is going to be pi times d squared, which is 0.11 squared over 4. Okay, times the height now that we have got here, which is on the plunger. This is what we have, the height here of 0.12 meters. Okay, so it's going to be 0.12 times now the efficiency. All right, and we have got our efficiency here. All right, and our efficiency is what, 93. So you're going to multiply by 93, in this case 0.9. So if you use it like this as efficiency like this, you use it as 0.93. all right, I think you understand what I'm trying to say. Like if you use it as 0.93 like this, you divide. If you use it as the normal way, then this is going to be efficiency on top over 100, but it's not the way that we are doing this way. So you can just use that way, still you are going to obtain the same answer either way. So that is going to be the number of pumping strokes, whatever that you're going to have. So this you can put it in a bracket so that it can be an exact answer there. So that is going to be 25,53467, something like that. That's what this is what you're going to have from a calculator, something like that. And these are number of pumping strokes, which means we must expect something like what, something like a whole number there, because you're talking of what, pumping strokes, number of pumping strokes. That's a whole number. So this definitely can approximate like to 26, but if you just round off this, it can be a 26 there. So you've got 26 pumping strokes in this case. These are the pumping strokes that we have. All right, so that's what we had. And I don't know if we clearly understand, but as you can see, guys, it's a matter of like formulation of formulas and working around the formulas. Yeah, that's the major part that you're supposed to actually do there. Okay, let's see this one, which is on 6.2, where we are given that there is the diameter on a piston water. The one that we are given is 210 millimeters. These are in millimeters, and we are also given the water pump delivers 0.41 cubic meters of water per operating stroke. Okay, the stroke force on the piston is 7.5 kilonewton. So this is like okay, let's just take this way. We've got a diameter here, so this is actually 6.2. So let's just take it this way. All right, so we've got a diameter that we are given here on the piston, that is the diameter of the piston there, which is 210 millimeters. So 210 millimeters, which is, if you divide by 1,000, that's 0.21 meters. And you're given the water pumps. This is the volume of water per operating stroke. Okay, so we have got volume in this case of 0.412 cubic meters, and this is per operating what? Per operating stroke. And in this case, we have got the operating force on the piston, that is the force that is applied, which is 7.5 kilonewton, and 7.5 kilonewton means 7,500, because you're simply multiplying by 1,000. The kilo means 1,000, so that is your actual force that you're going to have. So remember, guys, this is the volume per stroke. Volume per stroke, which means we do not know like the stroke length that we are going to have in this case and so forth. Okay, so the first question is, now calculate the stroke length. Calculate the stroke length, which is you are referring to h if you're talking of a volume. And we know that volume, like I said, from the here we do not have like efficiency and so forth and this and that, so we can actually take our volume direct into formula, because we know that actually volume is equivalent to the area times the height, and this is a circular part because we are given that it is got it's a water pump. It's actually a water pump that has got a diameter of this and that. So this is going to be pi d squared over 4. As we know, guys, the area pi d squared over 4, that is your times the height. So you can actually play around this. That is the volume that you're given divided by the area is going to give us your h, which is the height, that is the stroke length. So which means h can be given by the volume, because we have got this volume here over the area, which is pi d squared over what? Over 4. This is your area. So it's like volume over area, just like that. Okay, so your volume in this case, like I said, we have got the volume per operating stroke, which is this one of 0, so the volume is already there, 0,4132. This is 412 cubic meters over the area, and our area in this case is the one that we are referring as this. So you can write it as area or put it like this. So this is going to be pi times d squared. Where is our d? We just get this information. Okay, that's here. Our d here, that's 0.21 squared. So we've got 0.21 squared over 4. So this is what you're going to have at the end. So you can actually simplify further here using your calculator from the information that you have got. And I think, yes, everything is there. We've got all that we need. So h is going to give us something like 11,875. That's 895 actually, 89511, yeah, 7, like that. So that's your h, which is going to be 3 decimal places. That's 11,895. This is not going to change. All right, in meters. So that's your h, guys, which is the stroke length in this case, because you remember you're calculating the stroke length. So that is how you simply have this information. All you need is to just understand the basic of the information, how you work out the information, how you present your information, something that is very, very important. And still we need this maybe later on. Let's see what we've got here, where we are given to calculate now the work done per operating stroke, and that is actually just 2 marks, work done, because they know that if you have got the height and the force, you can calculate the work done. Remember, work done, that's 6.22. Remember, work done is equivalent to force times distance. So in this case, our distance, like distance, let me write in foot, but the distance that we are talking about in this case is the height that we are talking, which is the stroke length, because we are talking of the operating stroke, which means it's going to use the stroke length. So that is going to be FH times the stroke length, which is H, or just SL for stroke length. Okay, and we listed all this information. Your F, the force, is given as 7,500, which is 7.5 kilo. 7.5 times 10 to the exponent of 3, or you can just write it as what? As 7,500. So you've got 7,500 times the height that we just calculated now, which was, remember, your height was 11, this height that you had here. So it's the one that you're going to substitute, 11,895 meters. So that's what you're going to have as your work done at the end. And if you were to multiply it properly, this is going to give us something like 89212,5. And remember, your work done is measured in joules, and the instruction is just work done. You're not given to calculate this in kilojoules or what, so you can just leave your answer like this, or someone can just write this in kilojoules, and it will be like remember, I told you to convert to kilo, you divide by 1,000, and your answer is going to be definitely in kilo. So if you divide by 1,000, it is going to be 8,92125, which is going to be 21, like that, and that will be kilojoules. So that's the concept. Is it going to be 2389? Because this is 89. So that is what you're going to have. So it's going to be 89, because we've got 2 values here. So it's going to be 89,212, yeah, something like that. 89,212 kilo. Okay, so just divide it. The answer that you obtain from your calculator is the one, just because I was just looking at it. But use your calculator properly, guys. Okay, Don't assume like to say if I move this will come. No. Use your calculator direct. Okay. Anyways, let's see the other question. We just got the last part to mark it 3 marks, which is in order to us to have the total of 16, where we're asked to calculate the height of a circular dam. There is a circular dam that we have got, which is the diameter of 20 meters. So this is a circular dam that has got a diameter of 20 meters. If 250,28 kilojoules of work is needed, so we are given that we need a work of 250,248 kilojoules, which is a kilo means just times 1,000, or times 10 to the exponent of 10 to the exponent of 3. But we are given that there is also a pressure that is given of 380 Pascal. There is a pressure of 380 Pascal. So what is going to be the height of the circular dam? So calculate the height. So the question is for us to calculate the height. Okay, so how are we going to have this height, guys? And we've got a lot of things here that we like. What can we use? We're asking a lot of questions. Which part can I have? And we are given the work. Okay, remember that if I am given work done, okay, let's start with work done first, because it's like we have to start with what we have got. If I'm given this work done, I know that work done is equivalent to force. It can be times this, but I don't have that. So I can work with what? Pressure. Yes, I can even work with pressure, because remember, from your power is pressure times what? The given volume that you're going to have. But we do not have this volume, and it's the one that we need to calculate. Okay, so let's just write the formula. That's pressure times the volume. I have the work done, I have this pressure, so which means I can calculate the volume. But what is this volume going to help us? Because we know that here we are given diameter and so forth, so which means we can play around now the volume. We know that if we are given diameter, we can have area here, because area is equivalent to pi d squared over 4. And we know that volume is equivalent to, so let's just write it maybe here. All right, we also know that volume is equivalent to the area times the height. Okay, and as we want to calculate this height, so we can now formulate this to divide by the area Okay, so that means our h, which is the one that we want to calculate, which is the height, is equivalent to the volume over the area. Okay, so the area, now we said we can have this, the area can be determined here. Area can be determined here as pi d squared over 4, so which means area is fine. So area, we can have this. Volume, we said we can determine it from this, which means volume is there. So let's determine these two so that we can have our h. All right, so this is your volume divided by p here. So your volume is the work done over the given pressure. All right, so your work done in this case is a 250,248 kilojoules. So this is actually kilojoules, the one that we are given in this case. All right, so make sure that you actually apply your thing properly. So kilo means times 10 to the exponent of 3 or times 1000. All right, so you can multiply by 1000 over the pressure that you are given of 380. So we shall have our volume in this case, which is something like 6F, which is going to be 658. All right, 658,5473 and so forth. So it's going to be 73. So this is your volume in cubic meters. All right, and area, we said we can have this area from what? From this formula where we said pi d squared from this diameter here. We said we can have area here, pi d squared over 4. So that's going to be pi d squared over 4. All right, which is pi times d, our diameter we are taking from this information already. The diameter here, we have listed it down. Our diameter is what? 20 millimeters, 20 meters. So it's 20 squared over 4. So that will be your area in this case, and you're going to obtain something like 100 pi square meters as your area. Yes, someone can write this as a decimal, which will be something like 314,159, if not mistaken. That will be your area in this case. Okay, so if this be our area and this be our volume, it means we can play around now this formula now to find what the height that we need, because we want the height. So height is equivalent to the volume, which is 658,547 cubic meters here, over the volume, which is 314,159, which is in square meters. So as you can see, this will be in meters. All right, so dividing properly, we shall have our height in meters in this case, which is going to be 2,09622 something like that. Yeah, so you can have something like this, which is 2,096 meters. So this is your height. So guys, like I always say, that hydraulics, it's a matter of your formula, you and your formulas, knowing and connecting formulas. It's not like you have got something that is direct, that you're just going to from this stage I'm going to have this, from this one I'm going to have this. No, it's a matter of play around with your formulas. So the good part of working with this topic is that you have the formulas, and you can formulate from the formula that you are given to create even another formula if required. Then let it be like that. So these are the typical questions that you actually have from our past exam papers. So we shall have more questions to come as we be revising from Meson African motifs. So that's it, guys. Till I meet again.